Welcome to the lecture of Power System Operation and Control. Myself, Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So, students, today we are going to learn about the chapter 3, that is reactive power and voltage control. Okay, so we will begin with some of the definition and introductory part of the reactive power and voltage control. Okay. So students, these are the contents which I am going to cover in this video lecture. So first of all, we will start with the introduction, what is reactive power, and we will discuss the definition of the reactive power, what is the necessity of the reactive power in the power system. Then we will discuss about the active power and power triangle, and what is the role of power triangle which it will play in our power system, that we will see one by one. Okay, so we will begin with the reactive power. Okay, so here that is some of the terms that is related with the reactive power. So first of all, that is reactive power is an important quantity in AC network. Okay, and to define reactive power, let us consider over here, that is one circuit is given over here, that is the RL circuit. This is the R resistor is connected with the circuit, and this is the L, it is connected with this circuit. So RL circuit is connected over here in a load. There is a source is given, V is equal to Vm sin omega t. Okay, so over here V is equal to Vm sin omega t, so that is considered as the instantaneous voltage, and I, that is Im sin omega t minus theta, that is the instantaneous current. So two values are given over here, V and I. Okay, so V is equal to Vm sin omega t and I is equal to Im sin omega t minus theta, because we are considering that is, and in current is quite lagging behind the voltage, so that's why it is omega t minus theta is considering over here. So when you consider the instantaneous power, so this is the equation first of all, initial, or you can see the beginning of instantaneous power, that is equal to V into I. So when we put this Vm sin omega 2 t in place of V and Im sin omega t minus theta in place of I, then we will get the Vm Im sin omega t into sin omega t minus theta, and from that equation we will get this Vm Im divided by 2 into 2 sin omega t into sin omega t minus theta. So this equation is further, if we equate this, then finally we will get the 1/2 Vm Im cos phi minus 1/2 Vm Im cos 2 omega t minus theta. Okay, so when you are considering for the or going for the reactive power, that is reactive power, that is generally denoted by Q, that is equal to 1/2 Vm sin omega Vm Im sin theta. Okay, so over here that is Vm by root 2 into Im by root 2 into sin theta. So if you equate it is further, so it will be a Vm by root 2 into Im by root, it becomes divided by root 2 into sin theta. So it is nothing but the RMS value of voltage and current. Vm by root 2 is equal to Vrms and Im by root 2, that is the IRMS. So for reactive power Q defined over here, that is the Vi sin theta. Okay, so equation for the reactive power Q, that is the Vi sin theta. Okay, now we will see some of this discussion regarding the reactive power over here. So the reactive power does not contribute anything as far as work done or energy transferred from source to the load is connected. So it is not contributed anything, as we discussed, it is not contributed anything from load to source or source to load, that power is going to be faded. Okay, yet it contributes to the loading of the equipment, and the loading of the equipment is proportional to I and hence proportional to apparent power Vi. So the reactive power is a component of apparent power. How it will be the component of apparent power, we will understood by the power triangle. Now if we consider for the single phase circuit, the complex power S is equal to Vi star, where if you equate this equation S is equal to Vi star, you will get two components, one is real component and one is imaginary components, that is Vi cos phi plus j Vi sin theta. Okay, so we know that Vi cos phi, that is nothing but the active power P, and Vi sin theta, that is nothing but the reactive power Q. So your reactive power, that is nothing but the imaginary component over here, you can consider as an equation number 2. Okay, now over here there is a power triangle is given. Power triangle is given over here. You can understood this power triangle. To make this power triangle, we will consider this is the real power, okay, this is the apparent power, and this is the reactive power. Now real power generally denoted in kW, reactive power that is known as a kVAR, and apparent power that is a kVA. Okay, now we will see that is the generation of three phase power over here. That is, you can see from this is the blue line, which is stands for the current I, red line that is stands for the power P, and black line that is stands for the voltage V. Okay, and these all are the angles between the voltage and current. Okay, this is the angle between the voltage and current. So in, if we are considering this is the three phase motor, over there in there is an active power and reactive power is there. So combination of active power and reactive power, that will gives you an apparent power. So it is inductive loads requires two kinds of power to function properly. Okay, that is one active power, that is the actual performs the work, and reactive power that maintains the electromagnetic field. So these two terms are very important to understand. That is real, our whatever the motor which we are going to use, that is mainly consists of two component, active power and reactive power. And what is the role of active power and what is the role of reactive power, you can understand from this definition. Once again I will repeat you, that is active power that is actually performs the work. Okay, that actually performs the work. And what is the need of reactive power? It maintains the electromagnetic field in the motor. Okay, now if we see further for the three phase circuit, okay, for the single phase circuit, that is Vi cos phi, but when you are considering the three phase circuit, that is the active power P is equal to 3 Vi cos phi, that is the V phase I phase cos phi. Okay, so you can consider over here that is root 3 Vi cos phi for the active power, and for the reactive power that is 3 Vi sin phi. So this equation number 3 and equation number 4 is stands for the P and active power and reactive power respectively. Okay, now we will see what is the apparent power and what is the significance of apparent power over here. Okay, just a moment. So in power triangle we can see that there is a three triangle which is consists of active power, reactive power and apparent power. So we know that what is active power and reactive power. Now we will see what is the apparent power. Apparent power is nothing but the combination of real power and reactive power. We also shown in the figure of that motor. So here some of the statement that is regarding to the apparent power. So apparent power, that is the product of the RMS value of voltage and current in AC circuit, is called apparent power, and it is denoted by S. So active power is denoted by P, reactive power is denoted by Q, and apparent power over here you can see it is denoted by S. So apparent power is nothing but it is combination of V and I, voltage and current. So and it is measured in volt ampere VA. So students kindly remember all those notations, that is active power is denoted by P, reactive power is denoted by Q, and apparent power is denoted by VA. Okay, now active power, once again we will see what is the active power, the statement regarding the active power, and you can consider this is the summary of it. So the power which is actually consumed in an AC circuit is called active power. You can also define as or consider is it is a definition of the power which is actually consumed in an AC circuit is called active power, or it is the power which is actually dissipated in the circuit resistance. Okay, and it is denoted by P as we discussed. And active power, that is the equations for the active power, voltage and active component of current, that is Vi cos phi, and it is measured in watt. Why we considering kW? Because generally we are considering the kilowatt. So K, that is stands for the kilowatt, that's why we considering as a kW. Okay, now for the reactive power, some of the statements we can consider over here. That is, power drawn by the circuit due to reactive component of current is called reactive power, and it is denoted by Q. So reactive power Q is present when voltage and current are not in phase. Or you can see, for the reactive power, it is also very important statement, student. That is, when reactive power Q is present when voltage and current are not in phase. So that means there is a phase angle cos phi, or you can say that is a phase angle existing between the V and I, and there is existence, or there is the reason of reactive power is produced. So reactive power Q is present when the voltage and current are not in phase. In this situation, the current can be split up into two components. Okay, one component which is in phase with the voltage called active current, and which is the responsible for transmission of active power. So whatever the current which is phase in with the voltage, that is the responsible for the transmitting the power through the transmission line. And one more component that is remaining, that we will discuss, that one more component, there is another component which is quadrature called reactive current, which is not in phase with the voltage, that is the reactive current, and which is commonly considered as the generator of flux in ferromagnetic circuits such as transformers, motors, ballasts, etc. Okay, so reactive power, that is the equation for the reactive power, that is voltage and reactive component of current, so that is nothing but the VI sin phi, and it is measured in VAR or in kVAR. So similarly, we are when we considered in kilo values in kilowatt, so over here that is that's why we are considering it is in kVAR. Okay, now once again we will see, that is the power triangle gives the relationship between kW, kV, kV and kVAR. So students, now you are able to understood that what is the power triangle over here. So it is the power triangle that is given as the relationship between kW, that is the active power, kVA, that is the apparent power, and kVAR, that is the reactive power. So students, you can see over here this horizontal line that is stands over here, that is for the active power. This is the reactive power as we discussed, that is the Q, and you can see that is the real power, or that is the apparent power. You can see it is considered it is denoted by the S, and it is the angle between this active power and reactive power. Okay, that is the angle theta. So that's how this power triangle is formed. Once again, this vertical line is for the active power, there is an angle between the active power and reactive power. Okay, and reactive power considered over this vertical line, and this is the apparent power. That's how the power triangle is formed. Okay, so some of the term regarding the power triangle, that is theta is the phase angle as we discussed, that is theta is the phase angle, and the cosine of theta gives the power factor. So the cosine of the theta, that will give you the power factor. Now what is power factor? That is power factor, the equation of the power factor is equal to cos phi is equal to active power divided by apparent power, is equal to, what is active power? Active power nothing but that we have discussed, that is kW, and apparent power, that is the kVA. So the kW by kVA, or P by S, or active power by apparent power, which will give you the cos phi, or it will give you a power factor. Okay, now for the sin phi, that is the reactive power by apparent power, that is Q stands for reactive power and S stands for apparent power, and over here kVAR by kVA, that will give you the sin theta. Okay, so you can see reactive power Q, kVAR is equal to kVA into sin phi. So finally you will get the reactive power, and if any one of the value is given in the example or in the examination, so you can find out from that. If kVA is given and sin angle is sin phi is given, that you will be find out the easily the reactive power of that particular system. So students, I hope you understood the basic introduction of real power, reactive power, apparent power, and the power triangle, because it is the base of this chapter. if you do not understand this, so further theory it is quite difficult to understand if you do not understand this theory. Okay students, so is as per the every discussion of end of the lecture, I am just trying to remember you that please turn off the light when it is not required, and save the energy. Okay, thank you very much once again students.